Okay, let's have a look at this question then, which is paper 1. I think this is specimen 2. Specimen 2, question 2.1, 2.2 and 2.3. So I'm looking at question 2 on specimen 2 of paper 1. This question is about enthalpy changes. Write an equation including state symbols, so that's solid, liquid, gas, to show the reaction taking place when the standard enthalpy of combustion of ethanol is measured. So for standard enthalpy of combustion, what that means is standard means that I've got 1 mole of ethanol being burnt or combusted. Combustion's a reaction with oxygen. So I've got 1 mole of ethanol. Ethanol is CH3CH2OH, or you can write it C2H5OH, whichever. I've got 1 mole of it, that's important for standard enthalpy, 1 mole. Combustion, a reaction with oxygen, we'll look at why there's a 3 there in a minute. What do chemicals, organic chemicals with carbons, hydrogens, oxygens make when they burn? Carbon dioxide, as long as there's a plentiful supply of oxygen. So you get complete combustion, carbon dioxide and water. Okay, let's measure, let's see if we can work out the state symbols then. Ethanol is a liquid at room temperature. So this is standard states, means how you'd find them in the lab. Liquid, oxygen's a gas, carbon dioxide's a gas, and water is a liquid. Okay. You might be able to get away with gas here, depending on how hot it is. It may be steam, but water is a liquid at room temperature. Let's have a look now. 2 carbons, 2 CO2s, fine. 6 hydrogens, 3 waters to make 6 hydrogens. 2 times 2 is 4, times 3, 3 times 1 is 7. There's 1 in there, so we need 6 in here, 3 O2s. Okay. State the name given to the enthalpy change represented by the following chemical reaction. Okay, so I'm making carbon monoxide. Okay, so from carbon and oxygen from elements in their standard states. So carbon is a solid at room temperature, oxygen is a gas at room temperature. I'm making 1 mole of carbon monoxide. So it's a reaction in which 1 mole of carbon monoxide is made from its elements in their standard states. That's called enthalpy of formation, making 1 mole of something from their elements in their standard states, i.e. how you'd find them in the laboratory. Carbon is a solid, oxygen is a gas. Okay, explain why it's going to be difficult to determine. Because in my previous tutorial I explained that carbon reacts with oxygen to make carbon monoxide, but it's difficult to limit the amount of oxygen in there. You could do it by, I don't know, a faulty gas boiler would do that and make carbon monoxide. So would a car engine where there's a limited supply of oxygen and you get incomplete combustion. But most of the time it's going to be very difficult to limit the amount of oxygen. It's going to react with a plentiful supply of oxygen, actually not make carbon monoxide. You're going to get complete combustion and make carbon dioxide. So it's difficult to prevent the carbon reacting with a plentiful supply of oxygen to form carbon dioxide. Now we're getting to a point where it's getting a bit tricky. Calculations are tricky. Standard enthalpies of combustion for carbon and carbon monoxide are -393 and -283 respectively. So what you need to do is, first of all, we need to be able to see this. I'm a visual learner, I'm sure many of you are too. I need to see it. So enthalpy of combustion of carbon. So what's enthalpy of combustion of carbon? It's burning 1 mole, so I've got 1 C. Oxygen, making carbon dioxide. Okay, C plus O2 makes CO2. 1 mole of carbon to make 1 CO2, 1 lot of oxygen. I need elements in their standard states. So carbon's a solid, oxygen's a gas, and carbon dioxide is a gas. But for this purpose here, it doesn't really matter. We're just dealing with numbers. We want to find out a number. Okay. Carbon monoxide, standard enthalpies of combustion of carbon. We've done carbon monoxide. So carbon monoxide is CO, 1 mole of it for standard enthalpy of combustion. Reacts with oxygen, we'll work out why there's a half there. Carbon monoxide, oxygen is going to make carbon dioxide. 1C, 1C, 2 O's, there's 1 there, so I want this to be 1O. Half times 2 is 1, half an O2. So now I've got the standard enthalpy of combustion of carbon monoxide. And it says they are minus 393, so this one's minus 393, and 283 respectively. Respectively means that it's in the order that's listed. So the standard enthalpy of combustion of carbon and then carbon monoxide, respectively means that this first one is for the carbon and this second one is for the carbon monoxide. So I've put those in there. Use this data to calculate the enthalpy change for the reaction in 2.2. Well, what's 2.2? Carbon plus half O2 goes to CO. So it's this one. So we don't know this one, and we need to find it out. So let's say it equals X. X is the answer that I want to find out. What do I do? Okay. So first of all, let's bring this up here. I want to find out that enthalpy change. I know that's like a quick route up Snowdon on the railway. Can't afford the railway, so I'm going to have to go use the pig track and the miners track. Okay, and I'm going to piece it together. Carbon plus oxygen going to carbon dioxide, so I'm going a different route now up Snowdon. Ah, right, carbon, and I'm matching it up. Carbon here that I'm starting with appears here, so I've got a match. Snap. I'm going to spin it round because I'm coming this way up the mountain. Carbon matches, so let's slot that on there as a match. Great. Have I got anything else that matches in my other equation? Because I've got to get from the start point to the end point, from Penny Pass Car Park up to Snowdon on the railway. This way is coming along this way. I've still got to get up to Snowdon. Still got to get up to the top. I've got to get to the same place. Let's have a look how this is going to match up. Carbon monoxide. Ah, I've got a match there. My carbon monoxide matches, look. So let's spin this one. Might end up upside down, but I think we can cope. And we've got a match there. Oh, and I've got a match on the CO2. I've got a perfect match. I've got a match on the CO. And I've got a match on the CO2. I have made one mistake though that I want to correct. Carbon monoxide's not a solid, it's a gas. Let's do a quick match again. Carbon monoxide matches. So this reaction here, coming down here, is minus 393. This reaction coming down this way is minus 283. Now, one thing I've not told you yet is I can reverse it. So I can say, okay, I know the enthalpy change for CO and half O2 going to CO2 is minus 283. If the arrow were going the other way, it would be I'd change the sign. So let's do that. Let's change it round the other way. So this way, going in the reverse direction would be plus 283. So I've swapped the reaction over. You'll see what I'm doing now. I'm going to match it up again. if it'll let me. Come on. A match. And I've got CO2 matching up and going to CO. Make it a little bit smaller if I can. And let me. Yeah, you can see that CO2 going to CO is now matching, and I've got the arrow, importantly, going in the right direction. So I've got to come round here and I've got to end up at the same place. So I've reversed this reaction and taken it the other way and swapped the sign from plus 283, from minus 283 to plus 283. So I've swapped it round so that my route and arrows go in the right way. So this one's coming down this way to here, to CO2. Now my CO2 is coming round here to my CO, and it matches. I'm coming round this way. I'm going a different way around the mountain, yeah, rather than going straight up the mountain on the railway. So this reaction here, just like going up the mountain, this reaction here is minus 393. This reaction coming up here, up to the top of the mountain, is plus 283. And it equals X. So, X, which is what I'm trying to find out, is minus 393 plus 283 and so this missing enthalpy change here that I don't know, X, is minus 393 plus 283 because this reaction needs to come round in the other way, and that equals minus 110. And because all of these are in kilojoules per mole, it's in kilojoules per mole, because enthalpy change, heat change, is measured in kilojoules per mole, means you've been using 1 mole of substance when you've burnt it, because it's a standard enthalpy, although there are no marks for that bit.